This is Russ Andersson. In this tutorial, we're going to look at calibrating a fairly distorted conventional lens. And we're going to look at a variety of the different output options in this process. So we're going to start out by creating a bunch of trackers at each of these different dots. And I'll point out, you'll see that this is a nice single piece of paper that the calibration dots are printed on. You never want to be assembling this from multiple little pieces of paper and try and tape them together or pin them together or glue them together. You're just not that good to be able to do that accurately enough. So we're just going to click no. We've got an array of dots. So now I'm going to do a Control A and then a numbers pad plus just to lock all these trackers up. You could actually track them through a bunch of frames if you had a couple different frames of the same calibration pattern. So next we'll go to the lens area and start up the lens master calibration. Gives you a bunch of different options here, and there are actually several different panels. So the first one is to say that we're going to do a fixed spacing. It's a fixed spacing grid, whether it's a checkerboard or the dots. We're going to use a linear lens model. You'll see that there are all these tooltips popping up to give you additional information. And we're selecting the quartic distortion calculation. So that has both quadratic, cubic, and quartic distortion terms that are being calculated. We are going to compute a lens center. If you've got a lens with only a little bit of distortion, it can be impossible to calculate that lens center accurately. Just the data isn't there. In this case, there is enough distortion, and you can look at like individual rows of this data and get some idea where that lens center is going to be. We are not able to compute the field of view because this is a linear lens and that data isn't present. So we turn that off. We've just got an estimated field of view here. If you want, there's also a little estimator that pops up the information from and lets you enter the focal length of the lens and information about the sensor size and lets you get a rough estimate at least of what the field of view is. We'll set the lens radius here to its default value of 1, which just says we're talking about the entire width of this image. So that's our first panel here. Now we'll move on to the second one. And this controls exactly what you do with the calibration once you've computed it. So we're going to say that we want to deliver an undistorted image for starters. We'll do recentering to account for that UV center that we've computed just by padding. We're going to get an LNI lens preset. And we'll just run through, maintain image resolution, yes. A little margin around the edges of the image, that's actually not applicable in this particular mode. You see there are a whole bunch of options here. We do want to apply it to the scene. We're going to put it with the scene file. There are different locations where we could put it. We'll just get our little warning for starters, which is this. It just says, hey, when this is running, SynthEyes is going to look like it's hung. Because it is driven by a scripting process, it can't be put in the background and have a little progress bar at this point. So it'll look like it's hung, but it's working away steadily. And now you see the results. And I'm just going to zoom out a little bit. And in the particular mode that we selected, the image always fills the output 100%. So the idea here is that we've got an image that's distorted that's coming in. We're going to take that distortion and produce a linear image with the lens center exactly at the center of the output image that we're creating. Here's the output image that we're creating, just extends to here. So its center is right at the center of that. And that matches up with wherever we've computed the center to be of the overall input image. And this is the kind of image we want to create if this is what we're going to deliver to the end customer. And you'll notice that initially we had the field of view of 50 degrees, but because we're only able to use a portion of this image, the actual field of view of the part that we're using is smaller than the full actual image that we started with. Now, the distortion process has also created a undistortion mesh, which can be exported as a unit to other applications. You can also, if you want, put a texture map on it, put the actual image as a texture map on it, and see what you've got going on. That'll match up with the image that we've got here that's been generated by the image preprocessor. So to take a look at the other options here, I'm just did the undo to undo that last run. We'll run the calibration again, and this time we're going to run it with the re-aiming option. We'll turn off our warning. And now you see that the input image is filling, the output image is filling much more what the original image was. Basically, it's kind of twisting and keystoning the original image to make the center of the image line up properly. So it's a bit more complicated of a processing effect, but it lets you use more of the incoming image. You'll see actually that the field of view going out is even slightly larger nominally than what was coming in, which has to do with the undistortion that's being done at the same time. So now let's take a look at our other options. Now we're going to go rerun. Now this is for the other workflow, where here the idea is that we want to ultimately produce results using the original image, using the image that still has the distortion in it. So our overall workflow is to go and add effects or create effects that match up with this version that's kind of the fixed up version, but ultimately we're going to go and redistort those effects so that they match up with the original image. We can composite the effects in with the original image that still has distortion in it. So this is an artistic choice of the director that they want to preserve the distortion that was present in the original footage, and you want to get the highest possible image quality because you're not really doing anything to the original image aside from adding the effects in it. You're not subjecting it to the resampling operations that are used to pull out the distortion. So again, with the padding option, we've added extra space around the image to make the center of the optic center of the input image line up with the optic center of the image that we're creating. So there's a bunch of extra space around the outside of the image. So, it winds up that it typically doesn't take up much more space on disk because that winds up getting compressed effectively. But it does make the images a little bit larger. If we want, we can use instead again, the re-aiming option here. Now you'll notice that it's a much tighter image around the undistorted version. And this is because we're doing a keystone sort of re-aiming of the image to correct for the miscentering of the original image. You'll notice also that this boundary has just been replicated out to the edges rather than being filled with black. And that's reflecting also that we're now using, instead of a lens preset file, we're actually using an image map file, an image distortion map, also called an SD map or a UV map. And it's storing how you do this distortion process and keystoning effect to do the re-aiming. So those images can be used in other applications to do the exact same undistorting and re-aiming that you're doing in SynthEyes, but do it downstream in Nuke or After Effects or something, so that you don't have to run everything through SynthEyes and back. So, that makes it a handy workflow approach to have these maps available. And if you notice, there's actually an option to produce those maps all the time. So this is giving you an idea of what these different options look like for what sort of output format you want, depending on what it is that you're trying to produce ultimately, and how much work you want to have going on. So just to point out now that to apply these, you can just go do a file new. So there's the image. Now if I bring up the image preprocessor, I can go and pull up that image map, say, and have it get applied. And now here I get that same cleaned up image again. So this is the process I do for my live images. I do that to my actual shot and apply this distortion to my live shots, not just to the distortion images. So that's how you can use the image map to apply the distortion. At the same time, or the same alternative, you can also go and do the same thing with the lens preset that we generated earlier. And in this case, instead of using an image map, it's actually setting up some of the different coefficients. Well, in this case, they're really stored in that LNI file, but it's setting up the padding numbers here to do the recentering. So it's a different sort of setup. Instead of the image map, again, you got a bunch of different choices here. And so the point of this is just to show what some of those different choices are like. There's a lot more details on all of this in the camera calibration manual that you can find on the SynthEyes help menu. So thanks for watching, and take care.